Solving quadratic equations. Okay, our objective for this lesson is to solve quadratic equations by graphing, solve quadratic equations algebraically, and then to solve some real life problems. First of all, what does it mean to solve an equation? Again, remember an equation is something with an equal sign in it. Okay, and if you have an open equation, meaning if there's something missing in it, like you don't know what x is, or you don't know what y is, or there's a missing variable in it, to solve an equation means to find the values that the variable can be. So find the value or multiple values of the variable. Find the values of the variable. And you actually spend a lot of time in Algebra 1 solving equations.
Bonnie Burke, line 1, please. Bonnie Burke, line 1.
Sorry about that. Okay, so what does it mean to solve an equation? It's finding the values of the variable. And again, in Algebra 1, you spend a lot of time solving equations, but your equations are what we call linear, meaning they only have one single variable and no exponents. For example, 4x plus 6 equals 24. You would solve an equation like that. But again, remember, our exponent here is always 1. It's linear. We don't have any x squared, so there's no x squareds in the stuff that we've been solving up to this point. Today, we're going to learn how to solve a quadratic equation, which means it has an x squared in it. And again, when you think quadratic, I want you to think x to the second, x squared. So we're going to learn some tips and tricks on how to solve quadratics. Oops, sorry, kind of got a little bumpy there. Okay, with an x squared in it. Okay, so there's basically, we're going to learn 3 main methods today for solving a quadratic equation. There are basically 3 different ways of solving, and all 3 ways will work, but some are more accurate than others. Okay, the first method is graphing. Okay, for our main method for graphing, we're going to use our calculator to do it. And you guys might say, well, that's awesome. We can use our calculator to graph it, and so then we won't have to do any of these other methods. I can always use my calculator. But using our calculator only works if our solutions are what I call nice numbers. Meaning they are nice whole numbers, like 1, 2, 3, -5, -7. But when you get into the not nice numbers, like with our square roots and our fractions, the graphing method really doesn't work. And that's where we need other methods. So using square roots again works if it's of a certain form. If we can get it to look like something squared equals some number, then we can use square roots to solve it. Okay, and then factoring then works if it factors. Okay, and there will be cases where something will not factor. Not everything is factorable. Not all trinomials are factorable. So if it factors, we'll look at factoring. Okay, so first let's go ahead and look at our graphing method. So we're going to solve each equation by graphing it. So again, we're going to use our calculator. So I'm going to graph the related equation because this is equal to 0. So I'm going to graph y equals x squared minus x minus 6. So I'm going to graph that in my calculator. So we're going to go to my y equals. We're going to graph y equals x squared minus x minus 6. And again, we use this button for my x's, that one right there. And then I'm going to graph it. So I'm looking for where this is equal to 0, because again here we have it set it equal to 0. So I'm looking for what x's make y 0. Okay, so let's go ahead and let's look. So let's look at my x's, and we can trace, and you can see here that the x is here, and x of 0 gives me a y of -6. I want a y of 0. So if we think about where is y 0 on my graph, well, y is 0 when it's right here on the x-axis. So I'm looking for the points on the x-axis. I'm looking for this point here. This point looks like it's -2. Let's go ahead and let's type in -2 and see if it worked. Yep, -2 did give me a 0. So when I put a negative 2 into this thing, it gives me 0. Okay, so then let's go ahead and so one of my solutions would be x equals negative 2. But if you notice, this has more than one solution because there's another point over here that makes it 0. So let's trace. It looks like it's at 3. Yep, 3. So then also x, comma, x equals 3. So there's 2 solutions here. So it has what we call a solution set. So a lot of times we write it in set notation. My solutions are negative 2 and 3. Oh, solution set, not ordered pair, solution set. So those are the 2 numbers that work. And if you try it, if we go back to our home screen, and if I put a negative 2 into this equation, so I take negative 2 and square it, minus a negative 2, minus a 6, we get 0. So negative 2 worked. Let's try 3. 3 squared, minus 3, minus 6, 0. Okay, so those are the 2 numbers that work in this equation. Okay, now for part B. Okay, so we have negative 2x squared minus 2 equals 4x. This one's different in that it doesn't equal 0. But I can make it equal 0. So basically, I'm going to make it equal 0. So to do that, I need to subtract the 4x to the other side. So then if I rearrange this into a better form, we like negative 2x squared minus 4x minus 2 equals 0. So now I have that equals 0 part. So then I'm going to graph it. I'm going to graph y equals negative 2x squared minus 4x minus 2. Okay, so I'm going to graph that. Okay, graph it. And then again, I'm looking for where this equals 0. Okay, and it looks like there's just one point right there. So let's trace. It looks like it's at negative 1. Yep, so x equals negative 1 makes it 0. This only has the one solution because that's the only place it crosses that x-axis. So really, for our graphing method, what are we looking for? We're looking for, really our x-intercepts there. But first thing through, you have to make it equal to 0. Make it equal to 0. Then look for those x-intercepts. Okay, now pause the video, and I'd like you to do your turn, number 1, parts A and B. So pause the video and do those 2. Okay. Now, next up, using square roots. So now we've looked at the graphing method, so now we need to use square roots. Okay, so now we're using square roots to solve. Okay, this works, using square roots works when you can get something on one side, something squared equals everything else. But this everything else just has to be a number. You can have no variables over on this other side. Okay, so first things first is you need to isolate the x squared. So get the squared thing by itself. So in this first problem, we have 4x squared minus 31 equals 49. So I need to get the squared thing, the x squared there, by itself. So we're going to add the 31 to both sides. So you have 4x squared equals 49 plus 31 gives me 40, 50, 60, 80. And then now divide both sides by 4. So x squared equals 80 divided by 4, which is 20. So I know that if I take x and square it, I get 20. So to undo a squared, this leads us to the previous section where 2 sections ago where we were reviewing square roots. This is why we did it. So to undo a squared at this point, I need to square root both sides. So to undo a squared, so x squared, if I can undo it by square rooting. But again, I had to isolate, I had to get the x squared thing by itself. So then x is going to equal the square root of 20. Okay. All right, so x equals the square root of 20. But again, when I square a number, if we look over here, if I take 5 and square it, I get 25. But if I take negative 5 and square it, I also get 25. So if I'm looking for what number when I square it do I get 25, it could be 5 or it could be -5, because when you square a negative, it gives you a positive. So here, by square rooting both sides, x could be either square root of 20 or it could be negative the square root of 20 if I'm looking for what do I square and get to 20. So we shortcut that by saying x equals plus or minus the square root of 20, because it could be either or if we're solving an equation here. Okay, and then I need to simplify the square root of 20. So we'd have plus or minus, that would be what? 4 times 5 is 20. So x equals plus or minus 2 the square root of 5. And we will discuss in more detail that whole plus or minus idea in class tomorrow. Okay. All right, so x is plus or minus 2 the square root of 5. So if I put 2 the square root of 5 in here for x, and you can actually check your work in your calculator on this. So if I take 4 times my x, which is 2 the square root of 5, and square it, then subtract 31, I should get 49, which I do. Okay, let's bring that same problem back, but instead let's do a negative. So let's insert, so second delete to insert a negative sign in there. So I'm now taking negative 2 root 5 and squaring it. I still get 49. So both 2 root 5 and negative 2 square root 5 work in this case. Okay, so let's go ahead and let's look at part B. Okay, so we have 3x squared plus 9 equals 0. So again, I need to get the squared thing by itself. So to do that, I'm going to subtract 9 to the other side. All right, sorry about that interruption. Okay, we were in the middle of doing example 2, part B. Okay, so we subtract the 9 over, so we're left with 3x squared equals negative 9. Let's divide both sides by 3. So we have x squared equals negative 3. So again, like this last step, this is where we do the whole square root thing. Okay? And then we would say x equals, and again, it could be the plus or minus the square root of negative 3. Okay, but if we look here, we have the square root of negative 3. So I'm looking for what number times itself could get me a negative. Well, over here, we talked about how negative 5 times negative 5 is a positive 25. So really, no matter what number, when I square it, I'm going to get a positive. So there's no way for me to take a number and square it and get a negative 3. And if you try the square root of negative 3 in your calculator, you get this. Error, non-real answer, quit. So you actually cannot take the square root of a negative. So this thing, in fact, has no solution. No solution. Okay, because you cannot take the square root of a negative number. All right, now for your example 2, part C. So this one looks a little different because I don't just have an x squared, I've got an x plus 3 squared, but really you do it in much the same way. You want to isolate your squared term. So my squared term is this thing right here. It's x plus 3 squared. So the 2/5 is over there hanging out. I need to get rid of it. So to get rid of a multiply by 2/5, I need to multiply both sides by the reciprocal, 5/2. So we're going to take this side also and multiply it times 5/2. So then these multiply to give me 1, 10 over 10, which is 1. So I'm left with x plus 3 squared equals 25 over 2. Okay, so I have an x plus 3 squared, so I have something squared. So to undo it here, we're going to now square root. And again, because I had the squared isolated. So the square root is going to undo the squared, and I'm just going to be left with an x plus 3 over here. But now on this side, I'll have the square root of 25 over the square root of 2. And again, since I square rooted both sides, it's going to be plus or minus. So the square root of 25 is 5. Oh, I didn't leave enough room. So square root of 25 is 5 over the square root of 2. So x plus 3 equals that. We don't like a square root in our denominator, so I'm going to have to multiply numerator and denominator by the square root of 2. So we'd end up with, sorry, I don't leave enough room, so I have another piece of paper. Go ahead, another piece of paper here. We're just going to add another piece of paper. Bottom. So we'll have x plus 3 equals plus or minus 5 the square root of 2 over 2, the square root of 4, which is 2. But that's x plus 3, so I need to subtract the 3 to the other side. Okay. So then x is going to equal, we normally put our plus or minus in the middle, so I'm going to put my negative 3 out front. I'm just switching the order, plus or minus 5 root 2 over 2. So x equals negative 3 plus 5 root 2 over 2 and negative 3 minus 5 root 2 over 2. And if you were to substitute those back into here for x, it's doable but kind of messy. Okay, you'd end up with this thing right there. Okay. All right, now you have some your turn problems. Okay, so I want you to attempt your turn number 2, part A, part B, and part C. Get started, get something going on every single one of them. And remember, what's the first thing I did on these problems was I isolated my x squared. I got my whatever was squared by itself. So I want to get, for your turn, I want to get this x plus 2, this x squared by itself. Okay, again, for part B, I want to get this thing by itself. For part C, I want to get that thing by itself. Whatever squared, I want to get by itself. Okay, all right, next page. The zero product property, okay? If I have the product of two expressions and I get 0, so meaning I'm multiplying something times something and getting 0, then one or both of these two things must be 0, because the only way I can multiply and get 0 is if one of them 0. So if I'm multiplying two things, a times b, and getting 0, then I know either a is 0 or b is 0. Okay, so if I multiply a times b and get 0, then I know a is 0 or b is 0 or both, one or the other. So we actually use this then to solve equations, okay, to solve quadratics, because we can factor them into the product of two things. Okay, so again, the first step. So now we're going to move on to solving by factoring. Okay, so again, this is why we did all that factoring practice before. Okay, so first things first is factoring. You do it a lot like solving by graphing. First thing first is you need to make it equal to 0. Because I need to multiply two things and get 0. So I need to make it equal to 0. So in this step, if we want to solve x squared minus 4x equals 45, okay, what I need to do is then subtract the 45 to the other side. So I'd have x squared minus 4x minus 45 equals 0. So I've set it equal to 0. Now, take the trinomial that's left and factor it. Okay, so this is practice. Ignore the equal 0 for now. And I'm just going to factor this like we just got done factoring all that stuff last week. So let's go ahead and let's factor. It still equals 0, so I just write the equal 0 onto the end. Okay, my leading coefficients here is 1, so I'm just going to guess and check it. What multiplies to give me negative 45 adds to give me negative 4. So let's see, what multiplies to give me 4 to the 45? We've got what, 1 and 45, 5 and 9. If the 9 is negative, that'll give me negative 4. So plus 5 minus 9. Let's double check it. X squared minus 9x plus 5x gives me the negative 4, and then negative 45. So it worked. So now I have two things multiplied. I have this thing times this thing. Again, I'm multiplying between. So I know if I'm multiplying two things and getting 0, one or both of these has to be 0. So I know, using my zero product property up here, x plus 5 has to equal 0, or x minus 9 equals 0. Don't forget that or word in the middle. I expect to see that on your practice and on the subsequent quizzes. So now I've broken this problem up into two linear equations. So now I just solved this little guy, x plus 5 equals 0. So to solve that, what do we do? Subtract 5 from both sides? So x equals negative 5. Or, now solve this little guy. So to do that, we'd add 9 to both sides. So x equals 9. Okay. So then x is negative 5 or x is 9. So my solution set, this has two solutions, negative 5 and 9. And now if I was to check these, put those back into here. So if I take negative 5 and square it, minus 4 times negative 5, I should get the 45. Drum roll, please. Yep, it worked. Now if I put a 9 in here, 9 and square it, minus 4 times 9, I get 45. Yep, it worked. Okay. All right, so again, you make it equal to 0, factor it, and then what did we do? Set each factor equal to 0. Okay. All right, your turn. Now you have 2 your turn problems, part A and part B. So get those 2 problems done, attempt them. You need to have a good start on those 2. And then we'll start class discussing example 4. Okay, and your turn 4. So we'll start class looking at those 2. So get the your turn 1 through 3 done. Come to class ready to discuss.